For some reason when I first started 3D printing, I was afraid of using PETG. I don't really know why, but I had seen a few posts on Reddit asking how to print PETG and it kind of scared me off a bit. I was still getting comfortable with PLA and learning how to use the printer, so the thought of using a new material seemed like a bad idea. Once I got used to PLA, I thought it was time to try something new, and it turns out printing PETG is not that hard if you just follow a few key tips. So here are my tips to make printing PETG easy. I'll start with the most important tip, which is setting your Z offset correctly. That's the gap between your bed and your nozzle. PETG likes to print at a different height than PLA. You can think of it in terms of squish. PETG likes to kind of fall onto the bed, whereas PLA likes to kind of be squished straight into it. Not too high though, it still needs to be really close to the bed, it's just more of a relative thing. Now there's a few ways you can do this. The most crude way is to just manually go in and level your bed slightly higher, but I wouldn't recommend doing this at all. The best way is to simply set it in your slicer.
So it doesn't actually show up by default, you have to go into Marketplace and then go over to Z or Z offset and then it should appear here.
Another way to do it is to go into your printer settings and change it there, but you just have to remember to change it back depending on the material you're using. Just remember, increasing the number increases the gap and decreasing the number decreases the gap. The next tip is to get your temperatures correct. PETG has a higher melting point, so you need to print at a higher temperature than PLA. I generally print with a nozzle temperature of 235 degrees Celsius and a bed temperature of 75, but every printer is a little different and every brand of PETG is a little different, so you need to print according to your printer. The best way to find the right temperature is to use a temperature tower. The way these work is the nozzle changes temperature at a certain height, which allows you to see all the different temperatures in one print and how they affect the print. From there you can inspect and see what temperature you want to print at. If you want to know how to set one of these up in your slicer, let me know and I'll make a video on it. Another thing you need to think about is the type of bed you're using. Certain beds handle PETG differently. For PETG, I really like these flexible PEI coated beds. It's easy to get it to stick to the surface, and once it's cooled, it's really easy to remove. If you're using something like a glass bed or a coated glass bed, it's recommended you put down a layer of glue to act as a releasing agent once the print is done. It forms a thin layer between the print and the bed because PETG sticks almost too well to these surfaces and it can be really hard to get off. In fact, I forgot to use it on this printer one time when I was printing a large flat object and it became really hard to get off and I scratched up the bed a little bit. The next tip is to set your cooling fan speed. With PETG, you want little or no cooling because you want that melted material to print slowly. This will help the layers stick together better and give you an overall stronger print. I usually print at about 20%, which gives you a good amount of strength and still gives you okay bridging and overhangs. And this is something you can play around with yourself and figure out what works best for your needs. PETG will be worse than PLA for overhangs, so make sure to use supports when you need them. And just to add to this, I like to add a little bit more of a gap between the print supports and the print, because PETG can stick really well to itself and it can make them really hard to remove. Another thing with PETG is that it can produce more stringing. This is due to the increased printing temperature and the reduced fan speed, and it can make it a little oozy. The best way to compensate for this is to increase your retraction settings. When your printer moves to a new spot, it pulls back slightly on the filament to stop the flow of material for a second. You can even see this in action if you watch your extruder closely. All you have to do is increase your retraction speed and distance a little bit if you're getting stringy. One more tip with PETG is to store it properly. PETG is hygroscopic, meaning it will pull in moisture from the atmosphere. This is even worse if you live in a humid climate. It's best to store it in a sealed container or bag to prevent this. If your filament does get wet, you can dry it using a filament dryer. You can buy ones that are specifically for 3D printing, but they can be kind of expensive and only dry 1 or 2 spools at a time.
Here's how to make the cheapest filament dryer. Get a cheap food dehydrator, remove all but one tray, get a bucket, drill some holes, put your spools on, bucket on top, and there you go, cheapest filament dryer.
When your filament gets wet, it can drastically reduce the quality. Now some people use their ovens to dry it, but I wouldn't recommend this because I've seen posts of people forgetting they're in there and then turning it on to cook something and it just leaves a big pile of melted plastic in your oven. So just go with my method, it's cheap, effective, and safe. Now that you know how to print it, why would you want to print it? Well, first of all, it's stronger than PLA. Like I said earlier, it sticks really well to itself, so it gives you really good layer adhesion. It also has a little bit of flexibility, which means it won't snap as easily. I know PLA can be kind of brittle sometimes. Right now I'm using it to print a new part for my LulzBot printer. It's also about the same price as PLA and it's also non-toxic, so overall it's a really good material to print with. Thank you for watching, I hope this helps at least a little bit, and if you liked the video consider subscribing and I'll see you next time.